Let's talk about crop factor and focal length. I have three lenses here that we're gonna compare on different crop sensors. Two of those lenses will compare on 3 crop factor. And the Samyang F2, we're gonna compare with 2 crop factors. So I'll frame a shot here and then I'll try the other lenses in another room so we have more distance to cover. So we'll jump to the computer and see the difference between them. So here we are with my little friend Jeff Hanman as a stand-in. So we're starting right now with the Micro Four Third straight. When I'm writing MFT is for Micro Four Third. Straight is because there's no speed booster. Here we have the first one with a 28mm on the Micro Four Third. This is with the booster, so there's a shift in the brightness. It is also reframing. It's adding a factor to the crop. The Micro Four Third is a 2x crop, and with a booster it becomes like an APS-C without a booster, so it becomes like a 1.5 crop. So this is with the booster, this is without the booster, and here is on the Nikon with a booster, and it is a 0.7x. Let's just bring a calculator. On 28mm on a crop factor, that times 2. So that's the equivalent of 56. So if we check the Lumix here, when putting a 28mm lens on a Micro Four Third with the 2x crop factor, you would get the result of a 56mm. If we compare with booster, you would get 28mm times 1.5. That will be equivalent of a 42mm lens on a Micro Four Third with a booster that equals an APS-C. And when you get to the 28mm on an APS-C with a booster like this one that I have on it, which is Kipon Nikon G-Nikon Z50. It just means that Nikon G lens will fit on a Nikon Z50, and their crop factor for this one is 0.7. So we have a 28mm on a 1.5 crop factor, so we have the equivalent of a 42mm, but we have a crop factor of 0.7. So that gives us the equivalent of 29.4mm, so it's almost 28. So what you're seeing here is almost the same thing as having a full frame. If you don't have a big room and you want to separate the subject from the background here, and you just have 3 feet that you can back up to the wall, this is the frame you would have. If you have an APS-C, this is the framing you would be able to have. But if you have like a full frame, right here and here, you would have room for 2 heads talking together at 3 feet and still blur the background. So this is the 28mm at 3 feet on the Micro Four Third with a booster, and on the APS-C. You can see here that I aligned the nose, and they're the same. So we have the same crop factor. It's just that the angle is different because the camera are not at the same place, and at 3 feet that's pretty close. Here we have the 15mm on the Micro Four Third straight versus a Micro Four Third with a booster. Like this. I align the face so the framing is moving, but you can see the space difference around the subject. So like here and on the right here. Then we have Micro Four Third straight versus the APS-C with a booster. So let's compare these one. So that's the Micro Four Third straight, that's with the APS-C. So that's the Micro Four Third, and this is the Nikon with a booster. Next one, still the 50mm on the APS-C straight, so a 1.5 crop versus the APS-C with a booster. So this is the crop, this is with the booster. Crop, booster. And this would be 50mm times 1.5, so that would be around 75. This time is the 28mm on the Micro Four Third straight, so a 2x crop, versus the 50mm on the APS-C with a booster. You can see that the size of the subject is about the same. If I switch from one to the other, this is the Micro Four Third straight, this is the Nikon with a booster. So if we compare the same 50mm APS-C with a booster against this time the Micro Four Third straight with a 50mm, and the subject is still aligned, now the difference is pretty impactful. So this is the Micro Four Third straight, and this is the APS-C with a booster, the Nikon here. So that's near full frame. That's pretty tight. Now let's compare the 16mm on the Micro Four Thirds straight versus the APS-C without a booster. So this is the Z50 with the 16mm straight, no booster. This is the Micro Four Thirds. Both are at 3 feet. Again, the subject is moving because both cameras are side by side. The 16mm here, you can even see my shotgun mic right here. And here is the 16mm still on the Lumix GH3 or the Micro Four Thirds, but this time compared to the 28mm on the Nikon with a booster. The 28mm on the Nikon is a bit wider than the 16mm on the Micro Four Thirds, and that shows the difference between the different crops happening here. So you have the Nikon here, the Micro Four Thirds here, Nikon, Micro Four Thirds. The 28mm on the Nikon with the booster has an equivalent of a full frame lens. Micro Four Thirds has a 2x crop factor on the 16mm lens, which has an equivalent of 32mm lens. So we're seeing actually more a 32 compared to the 28mm on the Nikon with a booster. So this is like really a 28mm, and this one would be a 32mm. The next example is just the 60mm on both sensor but with subject aligned. This is the Micro Four Thirds and this is the Nikon. So the dial is aligned, so that's why the frame is shifting. And here are these three compared. 16mm on the Micro Four Thirds, then the 28mm with a booster on the APS-C, and the last one is the 16mm on the APS-C without a booster. So Micro Four Thirds, APS-C with a booster, and APS-C straight but with a smaller lens. Okay, we are now in a larger room with the camera at 5 feet. Here is the 28mm on the Micro Four Thirds. Here on the Micro Four Thirds with a booster. And here on the APS-C with a booster. Here I'm switching between the Micro Four Thirds and the APS-C with a booster. You can see a huge difference with this 28mm. Here is the APS-C with a booster, but zoomed in at 200% and centered on the subject. You can clearly see that the field of view stays the same once the frame is cropped to fit the Micro Four Thirds because the camera position has not changed. So it means that if I put a 50mm lens on the Nikon with the booster, I should have around the same field of view as the Micro Four Thirds, like this. But let's align the subject for a better comparison, like this, maybe. So I'll try it like this. So here's the subject aligned. You can see a small difference in the field of view because the 28mm on the Micro Four Thirds would actually be the equivalent of a 56mm, but we have a 50mm on the Nikon, so there is a 6mm difference right now, but pretty close. We can see another thing happening here. Look how the background becomes more blurry compared to the Micro Four Thirds. Micro Four Thirds, the APS-C with a booster, and look in the left corner here, the Kindle jar and the other things on the shelves here. Look how they become more blurry here. So you see the little difference of field of view because of the 6mm difference, but you also see that the 50mm at the same distance give you a way different depths of field than the 28mm. Now we'll see the three crops framed to look the same, but the camera position is moved at each one to compensate. Here is the 28mm on the Micro Four Thirds at 3 feet, followed with a booster added, now at 2 feet and a quarter. And here is the 28mm on the Nikon with a booster at 1 feet and 3/4. It's reframed in the canvas because of the tripod limitation on this shot. So the 28 at 3 feet, at 2 feet and a quarter, at 1 feet and a 3/4. And this is compared with the Micro Four Thirds without a booster and the Z50 with a booster. And here's the 50mm on the Micro Four Thirds at 5 feet and 1/5. On the Micro Four Thirds with a booster at 3 feet 3/4. And on the Nikon with a booster at 2 feet 3/4. Again, reframed in the canvas for this one. Micro Four Thirds, with a booster closer, APS-C with a booster even closer. And again, you can see the difference with the depth of field and the field of view. And now here with me, and from a different point of view, the 28mm on the Micro Four Thirds at 5 feet, on the Micro Four Thirds with a booster at 3 feet, on the Nikon with a booster at 2.5 feet. And you can clearly see the difference in the depth of field when looking at the background. Just look at the goofy picture or at the letters on the books here. So there's a big difference here. And with the 50mm on the Micro Four Thirds, this time we're at 9 feet. Here we're at 6.5 feet on the Micro Four Thirds with a booster, and the APS-C with a booster at 4.5 feet. So there's a big difference here. So if you're shooting in a small room, that's when the crop factor plays a big role. You might not want the artifact of a wide lens on a Micro Four Thirds in a small room for a talking head shot, just because you want a blurry background. Maybe the only f1.8 lens that you have is a 50mm, so right away you know that you'll need a booster or a full frame to fit into a small room. But also another thing happening is that mostly wide lens have the infinity focus after 3 feet or 5 feet, depending on the lenses. So if your subject is at 3 feet or 4 feet, that means that even if you separate your subject from the foreground, you already at infinity focus. But if you change the focal length to a step above and you put it on a booster, then you could be closer and still have room before reaching the infinity focus point. On this Nikon here, infinity focus is after 30 feet. I have another lens that the infinity focus is after 20 feet. On that Samyang here, the infinity focus is after 3 feet. So again, it doesn't give you a lot of play. So the bottom line is that you can always manage to get your shot, but knowing these differences can save you some time finding the right combination before the setup. I hope you like this video. Thank you for watching.